So in the case of single random variable, the probability density function, distribution function, conditional probability, everything will be function of only one variable. Okay. So in this chapter, we'll be discussing about multi-random variable. Multi-random variables are very important for analysis in the real-time situations because whatever signals occurring in real time, whatever variables occurring in the real time or multiple dimensions. It is not single valued, it is multi-dimensional, that is two or more. Okay, so that is why it is much important to understand the analysis of two random variables. Okay, so that is why here in this chapter will include probability function for two random variables. Okay, here we will be discussing what is the probability function for two random variables. Okay, so first we'll discuss what is joint probability distribution function. Okay, so since we are discussing what is the probability for two random variables here, that is why the name called joint. Whenever the joint is coming, it is not function of one variable, it is function of multiple variables. Okay, so whenever it is function of multiple variables, we call it as joint. Okay, and whereas in the single random variable, we have discussed that we call this distribution function as cumulative distribution function. So we will be writing it as fx of x, like this. Capital F we use for cumulative distribution function. It is function of only one random variable. Okay, so what is this? This can be written as probability of x less than or equal to x. Like this we will be writing the cumulative distribution function. Okay, so for example, here capital X, the capital X is given like this. Okay, so capital X is nothing but the random variable, whereas the elements of the random variable is given as 1, 2, 3, 4, 5, 6. These are the elements of the random variable. Okay, in this case, if you want to find out what is the fx of x for, okay, it is given that we have to find out the probability for x less than or equal to 3. So in this case, how do you write? We will be writing it as probability of x is equal to, it can be written as probability of x is equal to 1, probability of x is equal to 2, plus probability of x is equal to 3. Like this we will be writing. Okay, so this is in the case of single random variable. Okay, so since we have taken probability of x less than or equal to 3, for x less than or equal to 3, whatever elements you have, so you have to consider all the elements here. So it is since less than or equal, no, since that is why what is that elements we will be taking 1, 2, 3 here. Probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3. Since it is equally likely occurring event, the probability of each outcome is having the probability of 1 by 6. Okay, so it is 1 by 6 for x is equal to 1, 1 by 6 for x is equal to 2, and 1 by 6 for x is equal to 3. So what is this value will be equal to 1 by 2. Like this we will be finding what is the distribution function in the case of single random variable. So in this particular topic we will be discussing what is joint probability distribution function. So joint means what? We will be applying this for multiple random variables. So in this case, we are taking two random variables. So the random variables are capital X and capital Y. Okay, the elements of capital X we write it as X, and the elements of capital Y we write it as Y. So we know that the random variable will be represented with the capital letters, the elements will be represented with the lowercase letters. Okay, so this, because we have taken two random variables, these elements are represented in XY plane. Okay, we are representing these are in XY plane. Okay, now what is that? We are ordering, we are finding what is the ordered pair of x and y. So for example, here x is given like this. Okay, so x is given as 1, 2, 3, 4, and y is given as, for example, okay, so y is given as, for example, it is given as -2, -1, 0, 1. Like this it is given as like this. Then we are pairing this 1 minus 2, 1 minus 1, 1 0, 1 1, 2 minus 2, 2 minus 1, 1, 2, 0, 2, 1, like that we are pairing this. Okay, so this ordered, we are pairing in order. Okay, so the ordered pair of numbers x comma y is called random vector in two-dimensional product space. Okay, so or it is also called joint sample space. Okay, so the ordering pair of the numbers x comma y is called what? The random vector in the two-dimensional product space or joint sample space. Okay, so this is called joint sample space or two-dimensional product space. So this combination is called random vector. Okay, so now what is that we have discussed? So here we have considering two events. A is defined like this: x less than or equal to x, and B is defined as y less than or equal to y. So these are the two events. Okay. Now what is that we are doing? We are finding the joint probability distribution function for joint events x less than or equal to x, y is less than or equal to y. So it is defined as, how do we define it as? Capital F x comma y of x comma y is equal to probability of x less than or equal to x, y less than or equal to y is equal to. So since it is joint, no, joint means what? Intersection. So we are checking for the common occurrence of these two events. Okay, so that is why. So what is this x less than or equal to x? X less than or equal to x is nothing but a. Y less than or equal to y is nothing but b. So this joint probability distribution function is nothing but probability of A intersection B. Okay, so now what is that? Here we have considered a discrete random variable. In that case, x is defined like that. X is having the elements x1, x2, so on, xn. These are the elements of capital X. Okay, y1, y2, so on, yn are the elements of capital Y. So with the probabilities, what are the probabilities of that? Is probability of x1 comma y1 will be, what is the probability of getting x is equal to x1, y is equal to y1? So that gives us what is the probability of xn comma yn. Okay, now the joint probability distribution function for single random variable, if you take for a discrete case, so it is given as fx of x is equal to, so it is summation I is equal to 1 to n. Okay, p of xi. So 1 to n p of xi. Okay, u of x minus xi. This is the formula for finding what is the distribution function for single random variable. Now we are finding what is the distribution function for multiple random variables. So that is why we will be having, in this case we have taken two random variables, we will be having two summations. If you take n random variables, then we have n summations. Okay, so fx of x comma y is equal to summation n is equal to 1 to n, summation m is equal to 1 to m. Okay, p of xn comma ym, u of x minus x1, xn, u of y minus ym. Here, in the case of single random variables, we will be having the step function only once, whereas in the multi-random variable, in this case, we have taken two random variables, no? So we'll have two step functions. Similarly, if you take n random variables, in that case, we have n step functions. Okay, so if we extend this two random variables to the n random variables. So what are the n random variables we have taken here? X1, X2, so on, Xn. These are the n random variables. Okay. Whereas small x1, small x2, small x3 are the elements of this capital X1, X2, so on, Xn. So in that case, what is the joint distribution function? The joint distribution function is given as probability of x1 less than or equal to x1, x2 less than or equal to x2, x3 less than or equal to x3, so on, xn less than or equal to xn.